Hello guys, welcome back. It's Electronics channel with a brand new video, and today we have something really special. As you can see on my brand new display, I have a adjustable ATX power supply module. So what this will allow you to do is you can plug in any ATX power supply and convert it into a power supply pretty much that you can use all around your lab. Now what is special about this one is not only you get your 12 volt rail, 5 volt rail and 3.3 volt rail, you also get a ground output, and you will have an ability to go from 1 to 28 volts DC at 2 amps. So yeah, that is really cool. I'm really excited about this one. So stay around, watch this video, and you'll know how to make one. So the reason why I'm doing a module instead of a hacked ATX just like last time is because we have run into a problem. There's no way in the world I can replicate the results of this power supply. It just doesn't work. I have destroyed 3 ATX power supplies, and that's it. I'm not gonna try anymore since I have 2 pairs left that are exactly the same. So I will need those for my lab power supply. But this one was a total success, not only practically, but in the video. That's good. I'm really thankful to all of you guys that have watched that video. You are amazing. The whole video has more views than all of my channel, so that is just fantastic. So essentially what we are doing is I had thought of a circuit, a simple circuit that will be able to work really well. So essentially what we're doing is we're taking an enclosure like this, and we will insert a couple of things like an amp meter and the voltmeter in there. That's always a good thing to have. And we are taking this ATX connector. So you plug your power supply directly into this module, and this module will take care of everything else. It will start the power supply for you. It will have protection. It will have adjustable voltage. It will do everything really nicely, and this should be a total success. So the idea behind this thing is it will work very similarly to what you can buy on eBay or Amazon for ATX power supply. So you have your connector here where you plug in your power supply, and then you have a switch, turn the power supply on and off, and you will have your ground, 3.3 volt rail, 5 volt rail, 12 volt rail, which will be quite cool. Now another feature I will be adding into this power supply is an adjustable feature. Now there's many things you can do to make it adjustable, but a linear regulator and all of that. I'm not really into linear regulators anymore for power supplies. They're just a waste of time. We need a switch mode regulator, so that's what we're doing right here. So I have 2 boost converters. Each is capable of 2 amps. So we should have 4 amps of current when we put them in parallel. Don't make a mistake. You should always have a diode in series on the output for each boost converter. That's very important. Then we'll have large capacitance after the boost converters, and that will feed this buck converter. Now what the buck converter obviously does is drops down the voltage. So what we will do is I think I will give it about 25 volts, 30 volts or so. I think this meter is up to 30 volts or 100 volts. I'm not quite sure, but it did show 30 on my old bench power supply, so guess it's 30 is good. So we put 30 volts from the boost converters onto this buck converter. Now the buck converter will drop the voltage down, and you will be able to control the voltage with this 10 kilo ohm 10 turn potentiometer. And yeah, that should be all handy dandy. Now the idea is still in my mind, and as always, nothing is planned or prearranged. The circuit does not exist yet. So what we have to do is we have to build it. And when we build it, I will show you the circuit in the end of the video, just like always, or video description. And yeah, that should be all handy dandy. So first we have to cut a hole for the connector, glue it in place. Then we have to take our voltages and put them on the other side, and start putting the circuit in. And yeah, this project should be pretty cool. So let's start. So guys, we are farther into the project, and as you can see, we had made quite a bit of things. So first of all, we had drilled 7 holes for our terminals, ground, negative, 3.3, 5 volt, 12 volt, as well as positive and negative for the adjustable power supply. We had drilled a whole bunch of holes for our amp meter / voltmeter, and we had made knocked out the hole and glued just put a whole bunch of super glue on my finger. We had glued this connector here. So this is pretty much how the module will look like. So I will knock a hole, file the edges, put the casing in, then put the amp meter voltmeter in, and yeah, we can start wiring the thing. Oh, and we need a power switch as well. So yeah. So guys, we are farther into our project, and this is how it all looks. So 2 switches. There should be a third one, but after I cut a hole, I realized I have no space for my potentiometer, so I messed up, and I'm not gonna make another cover. So ironically, the potentiometer does fit really snugly inside of this hole. So this is how it's going to look, with a big knob like this in the middle. Looks really crusty, but yeah, that's all we got. So this will be an on-off for the whole thing, and this will be the switching for voltage between the 12 volt rail and our adjustable power supply rail. So yeah, that should be pretty cool. And yeah, all we have to do is start soldering all of this together and solder all the connections with a PCB and connect all the boost and buck converters, and we should be good to go. So guys, it is time to reveal the end product. Looks really good. So it's time to show the inside. Whoa, wires. Yes, there is a lot of wires in this particular project, because there is many connections here, and we are not using a PCB for a sake of simplicity. So essentially power comes in, goes through the relay, through normally closed contact right to the outputs. And then the power goes through the boost converter to the buck converter, and then it goes straight to the outputs. So what we're doing here is we got two switches. One turns on the whole thing. The second one turns on and off this relay, which disengages the outputs on here and switches the sense wire, this yellow sense wire, from the 12-volt rail to this guy. So we are getting voltage right on the plug here or here. That is really, really handy. So let me just put it all back together, put it all together, and I will bring my ATX power supply, we hook it all up, we do some testing, and yeah, we should be good to go. So guys, there we go. I have my test set up here, and what we have is, as you can see, the plug comes in, plugs right into the unit. We have our outputs on 12-volt rail. We have a big resistive load here, and ATX power supply here. So let's turn it on and see what happens. Well, right off the bat, you see that the thing is pulling almost 9 amps, and you can see it glow red hot. So it's measuring the voltage at the terminal, and it's measuring the current. So that is really, really good. As you see, working like no problem. Switch to 5 volts. It does not show 5 volts because it's directly connected to the 12-volt rail, since I thought, that's the most used rail by me, so that's where I have it connected. But as you see, all of the other ones do work. They do pull current, so 3.3 volts, 5 volts, and 12 volts. And it glows red hot. Pretty cool. So now let's switch to the other output. So as you see, when I switch over to the other output, the resistive load turns off even though the power supply is still on. So when I switch, boom, now we have only these two outputs enabled, and we have a full control over the voltage from 1.3 volts all the way up to 28, we call it 29 volts. The output is limited to 2 amps, so this is meant for electronics projects, not a high load application. But for high load applications, you have your 3.3, 5 and 12, so you should be good to go. And yeah, like this one is just limited to 2 amps with a fuse, and just for powering electronics projects, this should be just ideal, because you do have that control of your voltage, which you can set really precisely. 7.7, let's go 10.5. There we go. So really easy. And yeah, let's go 4.2 for charging batteries. There you go. So really easy to set the voltage on here with this 10-turn potentiometer. So let's now switch to the other output, and right away you see the coil turns red hot, and we're pulling 9 amps. And yeah, So yeah, I think this project is quite successful, and I really love the looks. So guys, this was a really cool project, and I hope you enjoyed it. This is quite a success comparing to, something you can just build with the LM317. LM317 just does not work for, any reasonable loads. We have 2 amps here, which is not much, but LM317 is only capable of 1.5 amps maximum. So you'd be looking about 1 amp that you would be able to use it for. And yeah, I mean, it's pretty compact. And the good thing is you take this anywhere, and you take any ATX power supply, you plug it in, you're good to go. I mean, who doesn't want something like this? This is absolutely cool. Really cool. So guys, that's about it for this video. You all know what to do. Like it if you like it, dislike it if you dislike it, and don't forget to subscribe to my channel if you hadn't subscribed already. And yeah, you're going to see some of my other videos on your screen. I really hope you click on some of them, and you'll make me the happiest person ever. And yeah, as always, see you in the next video.